Sorry about that. Maybe that reset when I retoggled the stream. Any main reason for doing sub only stream? Because I feel like it. Like with the way internet dynamics work, it's very taxing once you start getting people's attention on the internet, because you can easily feel woefully underappreciated and in fact abused, right? And so then if you're streaming to everybody who is woefully underappreciating or in fact abusing you for what you do, that just feels bad. So sometimes I like to do streams where I'm clearly not doing that, right? Um, that's all. So I feel like this is sub only weekend. Like tomorrow's marathon will probably be sub only, and then I'll go back to regular streamy streams for a while. It's just a fun thing to do once in a while. Rockets with glasses. That's pretty good. Deal with it. Okay. Anyway, right now we're looking at what can we do? What is there that can be done in the world of these things? And really, I mean, type inference is the slow thing, right? Like it's most of what the compiler does. And in fact, if you cut off waiting for the linker here, which is like 1.3 seconds, then, this is more than half probably. Hard to tell. Let's see what the exclusive percent is. Semaphore, wait for, infer types, yeah. Um, build for procedure, do polymorph. I wish I could like crop this out, the linker time. Wow, it's even more. It's almost half a second that we wait for the linker here. Okay. So I guess we look at infer types of queued. Like, look at all that. We have a lot of resolve one ident. But only 10%. That's still a lot. 50 milliseconds to look up identifiers. I mean, there's a lot of identifiers in a program. You could imagine that we cache them in, like if you use a variable in a procedure, right? You could imagine having a cache of like the last 3 things and just seeing if you hit that. We could actually, one thing we could do, I'm going to start writing down ideas of what to do, right? So, resolve one ident cache. The problem is you go into like subscopes so often that you'd probably be blowing away that cache a lot. What else? We could just look at main loop, thin out the main loop, thin out the, there's a function that dispatches to all the types that maybe does a little bit more work than it needs to, because yeah, what else? Can I like profile all of these together, or this is probably just for this one piece, right? Let's do this one and see if it's very different. Yeah, so this one has polymorphs and this one doesn't. How do I like add all these together? Anyway, so inclusive percent is, oh, this one has a lot of polymorphing in it. A lot of ident resolving, a lot more polymorphing. This is like half polymorph, more than half. Oh my God. All right, this one is not. This one is like resolve an identifier. Getting memory is like 5%. It's got a little bit of polymorph, but it was easy. Like, yeah, this is spending all its time looping through this frickin' thing for some reason. Because, like, it's exclusive 62. Like, what? Exclusive 30. Yeah, this loop is kind of expensive, I think, is what we're learning. Why? Why is it so expensive? Looking up identifiers is expensive. Inclusive percent 105. I don't know why that is. Let's just look at that. I've looked at it before, but maybe not as seriously. So that is this procedure. We do this thing where we ensure it's flattened, which is being called over and over every time people come back. So this could be filtered out. I think. Okay. This yielded on expression is like okay, this we kind of need. It's probably not that bad. You know, whatever's in here is going to be the expensive things. What's going on here? Need size to build batch. We go over every expression separately. I mean, how expensive is that? Need? It's like not even listed. Which probably means, oh, we didn't do a zone. Let's put a zone there. That could be expensive. That could be expensive. Let's delete this. So, this cursor we don't necessarily need to store on the data structure. I'm not sure how much that matters. We're checking this if statement. We're checking this. We're checking this. Like this is for every expression. Right here. This doesn't do anything in telemetry or release build, I don't think. Like there's just more if statements in here than we would like. Let's just see what this need size to build batch does. It might be too expensive. But it's also something we could break into like a separate thing. Whoops, that was release build, telemetry build. Okay. So this one, timeline, profile zone. Why isn't it here? Oh, did I build the wrong? I said TM function 0, 0. Oh, it's got interp : : right? No, it's typer : : need size to build. There we go. Um, it's only 5 milliseconds out of 500. So I think we do want to look at that. It is not the highest priority. Wait, need size to build batch, it was called. Right? And that calls need size to build. Wait, what? What? Why don't I see this? I'm not seeing the right thing, everybody. We're seeing this. Oh, I put the TM function in the wrong place. That is why. You must put the lotion in the basket or you get the hose again. That's the rule. That is the rule. Okay. Boom. Tomorrow we're doing a very long stream where I refactor the data structures on the compiler to be more parallelizable, and we see what happens. You realize there may be a connection to the fact that all computers move to x86 and RISC processor dies in the public PC market. I don't think that has anything to do with anything. I think CPU technology is doing great compared to software technology. The problem is not hardware at all. The problem is software. Okay. Why doesn't that work? Typer need size to build batch. Okay, 8 milliseconds plus 5 for both of these is 13. But out of 500, that's still not that much. Or no, out of 300, it's significant, but I think still not the place that we want to focus yet. When a compile work unit is done and there are multiple sleep yields waiting on it, how do you decide what will continue? I don't care. I just wake them all up. They just go back into a queue. They don't like start immediately anyway. It's not like you hand control to that thing. It's like they just go back into a queue of what's live, and then the thing that's handling that queue picks up whoever it wants later. When was the last time software was doing better than hardware? Never, as far as I know. It's not like there was ever a time when that was true, as far as I know. Okay. Need size to build batch. All right. So we will come back and look at that. So our note here will say this takes about 8 milliseconds. Takes about 8 milliseconds on Sokoban out of 565 milliseconds spent in infer types queued. So it's really not that big, right? This is the exclusive time, yeah. Okay. So like we could avoid writing the cursor back. I don't know if that helps. Like, okay, instead of writing the cursor back here, it's not really going to matter. Like, because we're going to have to spill it to the stack probably anyway. Because we're calling stuff that could go quite deep. So I'm not sure there's really any profit in storing it in a local variable. Oh, except aliasing. Aliasing might make it worth it. Okay. Here we go. Here we go. Let's try this. Okay, you know, this is the kind of thing where maybe you do it and it doesn't help, right? Okay, if we reported an error, who cares? We ask about the cursor. Okay. And then we go cursor plus plus. All right. So down here we go. We're going to assert that cursor is equal to flattened expressions.count. Maybe that's fine. Let's see what happens. It's easy to screw this up. This is definitely a little bit more complicated. Okay, other things, we know that this doesn't change, whereas the compiler doesn't really know that. So again, we're copying it out of the loop. The compiler does not know. Does not know that. No, we don't want to run telemetry. We want to run debug. Uh-oh. We broke something. Hang on, let me... All right. You definitely broke something. Let's just set this, because we were setting this before. May not be necessary. Okay. So the thing is, whoops. Wait, what? Count is not a member of flattened. Okay, so used before its declaration. So I wonder if we're actually using. So there's two possibilities. One is I messed this up. Um, Two is somebody is looking at it. Somebody is looking at this cursor value in order to decide something. I don't think that's necessarily it though. Maybe it is. It's hard to say. Um, let's just say. Let's try that. Okay. So that fixes us, and this breaks us right here. Now we could, if we did this, it would probably still be faster because we're not doing a dependent read on this maybe alias thing. I mean, probably still negligible. Probably still negligible. But that's how performance is sometimes. You just add up negligible speed ups until you reach some discontinuity where suddenly you're able to do something really good. What is the weather going to be like at lunch? Looks like it'll get a little more sunny. Okay. So I could just break where we're getting this error and see what is going on there. That is one option. That might tell us very quickly what the problem is. It might not. It might be something we have to trace back for a while. I could just search through the file for like, does anyone read this? Why, yes, they do. Dang it. Okay, that's the problem. So this indexing outer is used when we queue things. And that's how we know where things are in the source code, right? Okay. So we need to write this for each expression right now, but we are not doing a read from it, so hopefully aliasing is limited. Can you do restrict on a local variable in C++? How does that work? C++ restrict keyword. What? Restrict type qualifier. Restrict semantics L value. If some object is accessible through P is modified, then all access to that object in that block must occur through P. Okay. So I can say this on a local variable. block scope that is limited to its block. It allows local assertions. I don't know why it's talking about macros. Convert a function that takes restrict qualified pointers. Oh, I see. Why? What? Oh, so your restrict is not contaminating whatever function this is in. Like, this is documentation that's still hard to understand, even though they're trying to explain, right? The point is, if you put it in a macro, it won't contaminate what's outside. But you wouldn't expect it to anyway? I don't know, dude. I don't know. Anyway. Isn't restrict no op in C++? I don't know. Is it? Is there no restrict in C++? Are you kidding me? Oh no, we're on Stack Overflow, guys. This is bad. Great. We're in serious C++ land now. Stack Overflow is quite helpful for beginners, sure, but beginners maybe shouldn't be writing as much code as they are. Okay. Like, if you haven't even heard that Stack Overflow is bad, like, that's such a meme. If you haven't even heard that, I don't know what to say. All right. I don't know why we're building release build now. Wait, what just happened? Did one of those compiles just... What? Did I... Or is that from yesterday? No, that's literally our first build did this. That's not good. That's probably not related to what we're doing. That's probably, ugh. Oh, well, there probably also was a race condition where we're loading the release build from last night. Like, Windows drives me nuts this way. Because we were working on that bug last night. All right. Let's just assume that that's not a thing. So down here, we're going to see if any of this like matters at all. So here we're going to say can I do that? See, I don't even know if this is legal because, like, I don't even know what this means because obviously these two point at the same thing, right? And they're both live in the scope. So, like, I don't even know how I'm supposed to use this. You can't use auto with restrict. Good job, guys. Good job, guys. Oops, that's release. We want debug. So that appears to work. Let's run that on tests. I'm not a fan of how that function got a little more complicated, but we'll see. What do I want from this restrict keyword? What do you think I want? Okay, so let's just find out that this did absolutely nothing for performance. And again, these are noisier measurements because we're streaming and stuff, but let's see. Timeline. Profile zone. Infer types of queued. Wait. Really? Exclusive percent 18? Hold on, let's clean all this out. Did that really do that much? Oh no, it was already 18. Yeah. 306 milliseconds. Well, I mean, our runs are so different time-wise. I wish it would highlight over here which one this is. Yeah, so basically no change that we could tell, except it's weird because it's like, so inclusive time 525, inclusive time 609. We just got a much slower run. Like, let's just try to get a less, okay, hold on. We're going to clean everything so that we know what it is. So here, this is the old one, 10:33 a.m. Now we're going to run 1.5. Okay, that's better. This one was 1.7, which wasn't so good. 1.62 seconds versus 158. Let's see if we can get one more that's maybe closer. 162. Oh my God, that bug is real. Dang it. Okay, we're gonna have to debug that. 164. All right, not helping. So we're gonna roll back to this one here, which is pretty close. Profile zone. 18.75% of 5 with 556 inclusive. 18.48% of 525. It's like, it's basically the same. What was done there didn't matter. That's a bummer, because I was hoping we would get something out of that. Like, this function really, it's really kind of heavyweight. It's oh, although no, it's not really. Guys, okay, I'm stupid. I keep forgetting that I'm using telemetry and not like our own profiler or whatever. We actually don't know, because these are manually marked zones. Okay. We're calling this a lot. But we're going to add something else that we're going to call even more. So we're going to have to roll this back. No check-in, undo this. It sucks. Okay. Like, we're just finding out what we can do. We're not like trying to actually do things. So this one, which we're not, no, not even this one. I'm looking for the expression version. This one is kind of nutty. And like, even this, like, could we possibly check this somewhere better? I guess the way we do this is not, if this were an actual operator, then things would work out. Like, yeah, making that not an operator is maybe a bad call, because it adds an if statement to literally everything. We could, and even if we don't get a noticeable improvement just out of commenting this out, there's this thing about optimization where you just need to make the code lighter. And even if something doesn't seem to weigh it down, the contribution of a bunch of things like that pretty much does. So anyway, what I was going to do is do something like this. I'll just do this. We're going to do this like speed. Do we really need this check? Kind of feel like we shouldn't. Maybe we should try to get rid. That's going to be a pretty cheap check, because I think it's a well predicted branch, but who knows? Yeah, okay. So we're going to run this. And that's actually going to tell. So I was assuming that this was all in the body, but that's in the body of that loop, but that's absurd. It's just, we didn't mark the things below it that it calls. So oops. All right. Okay, exclusive percent is only 5% actually once we do that, which is still a lot. Honestly, it's enough that we want to think about it. Whereas this, the expression version, is way more expensive, which is what we would expect. And we call it 800,000 times. Which actually, that's not that much more than this. So we only do like 4.2 expressions before we yield or finish, which is not great. That maybe means we're pushing a lot of small cues. Oh, cued optimization. Like we could generate fewer cues in many cases. That is definitely a thing that could happen. Auto pointer. Oh, I guess you could put the pointer after auto. Auto is weird that way. Are there maybe already existing speed tags? Yes, there are many of them. But they don't work that. They're not going to tell me what's the slowest thing because I don't know. They're just going to tell me if I'm looking at a particular body of code that I see right now as being slow, they're going to tell me when I wrote that code what I was thinking about that might be slowing it down. They're not going to tell me global to the program what is making the whole thing slow. Okay. What then is going to happen here? Okay, I can't even tell. Is this from this? What? I don't know. Let's see. Timeline. Okay. I guess that was. Oh, wait. We already. Okay. Never mind. Because we didn't make anything faster. What I want to do is see, do we need this? Like, who is ever passing null in there? That's a thing that I could have seen happening in early versions of the compiler. I don't think it should happen now. But maybe it does. Doesn't seem to. So we can get rid of that. That's going to be a well-predicted branch. So it's not like that's going to be a dramatic thing to get rid of, but this thing gets called a lot. Every little thing that we get rid of is good. Would it make sense to do a prefetch? I don't actually know. That's something where I think we would want to get out a different profiling tool. Like, one thing we could do is try to use the Intel profiling tools again. That last time I tried to use them were a disaster. Because they tell you things like that. Like, oh, you were waiting here on memory, for example. Or, I don't know, they kind of do it with a simulator. I don't freaking know. Okay, so that can go. here, I mean, this should only happen if we're queued. Like, maybe we don't need this anymore. Because okay, hold on. Let's undo the stuff we did up there. Because I'm going to want to actually check some stuff in here. Oh, come on. Just do the whole thing, guys. Okay, we'll leave that. We'll leave that. We'll leave that. Boom. Boom. And we're going to save. And okay. So let's make sure we didn't hose that up. So this thing, I feel like we mostly shouldn't have to check this if statement. However, clearly there's this run directive case. And the thing is, do we need it? Right. So the places where this is called, I think, are only here. Right. So if it's queued, we handle it. Let's just see. I'm going to put an assert here, and I think it's going to actually fire. But I don't know. Yeah. Oh. It'll fire because like we substitute things that have inferred types on the yeah. No, this will fire like a lot actually. So this expression is a type definition. Yeah. Yeah. It's a pointer type. It might be like interp type def pointer to void or something. Yeah, no, okay. So I understand why that is. So we would like to get rid of this, but can't right now. But the data structure refactor we're going to do in the marathon tomorrow might have some bearing on this. Are there VTune equivalent things for AMD? I mean, I don't know. I don't know if AMD publishes those kind of tools. I feel like they should. Okay. Let's actually do this, right? Actually, so we never did a telemetry build from removing that expression. So we're going to do that. Okay. Let's get rid of all these. Whoops, we just got rid of the one we wanted. Okay. I think this was an unexpectedly fast one. Anyway. So infer types for an expression is like 16% exclusive. Here. Oh, we didn't have it. Oh, dang it. All right. Inclusive on this is 36. Inclusive on this is 40. Ugh. Yeah, these measurements are so noisy, right? It's just to say it was not an obvious drastic change. As I expected it to be completely non-measurable. So we're sort of verifying that. All right, now here, we're actually, I just want to see, I just want to see what happens here. Infer types of queued, inclusive 39. So that's basically, that's slightly fast. It's like in the noise, way in the noise of about the same, right? I mean, the thing is, it was 36 back here, so who the hell knows? Like maybe it's slightly faster, to comment that out, maybe not. I think the big wins, it's hard to get big wins from this. Maybe we turn spread into an operator so we can get rid of this. Okay. This it's hard the way it's structured to get a big win, because it's like it's a switch over all the node types, and what are you going to do, right? So maybe we just look down that profile and try to see what's expensive in there. We already know part of that answer, which is polymorphing is kind of expensive, but and we know identifier lookup is kind of expensive, but there may be other parts that we haven't identified yet. No pun intended. Or maybe yes, pun intended. I don't know. Okay, let's Let's go to exclusive percentages because we could see what we might break up like asteroids. So infer types, I mean, it just takes a lot of the time, and we don't have we don't have that broken up. I mentioned there are more ifs like that in other places for spread. No, there aren't. What I mean is that function that we're looking at gets called to type check every single frickin' expression in your program. So we're doing that if statement for every single expression in your program, which to be fair is less than I thought, but it's 800,000 times, all right? So I mean, really, that's even not that much, honestly. But yeah. It's just to say that that's kind of wasteful and stupid for something that almost never happens in your program, right? Like, how many times do we even use that operator in the whole Sokoban game? Like, it's just not that many. So it just shouldn't have an if statement that triggers for every expression, like just as a matter of basic self-respect, right? So back when I implemented that, I thought it was really cool. I was like, oh, I'm just going to flag an expression as having that operator because it's so easy. But like, honestly, no. Honestly, no. It should be done a different way. So I'm actually going to write that down. Maybe we do that tonight. Re-implement spread. And that'll just, that won't really make anything faster. It'll just make it a little cleaner. It just shouldn't work that way. There is uprof for AMD. Let's see. AMD muprof or uprof, depending on. Better understand the runtime performance. We could run this real fast, except I don't have an authentic AMD CPU right now. Not on this machine. I have one in the other room. I guess this is the Windows one. Let's see what happens. I totally accepted this end user licensing agreement. See what it's calling that and try to look for inexpensive ways to infer some types. I mean, I don't know what that suggestion turns into concretely. Inexpensive ways to infer some types is easier said than done. What we could do, we could have an outer loop. We could actually do some more accounting for types. Like, you remember the first thing we looked at was that outer loop that calls infer types a lot? That one, we might just be able to say, if we're looping over stuff and a lot of it is inferred, just don't even call. Like, that might be a cheap thing to do. It might be expensive. It depends. Whether that's cheap or expensive will probably change when we finish doing all this memory stuff that starts tomorrow. But we could take some accounting on that. I like that idea, actually. Like, just see what that looks like. Okay, we're totally learning about AMD muprof. Complete. I want the whole thing. Is spread here like the splat operator in Yulia? I don't know Yulia, or as people call it, Julia, even though that's a mispronunciation. But I assume so. I assume it is similar. But probably not, actually. It's probably pretty different. Okay. Profile and application. Let's go. Let's go. I bet this is going to be just as useless as the Intel one, but we'll find out. Boom. 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 Start profile. Okay, wait. Why did we run the telemetry build? That was not good. Hold on. It erased everything. Okay. Holy crap. Like, how hard is this, guys? Who made this? How is Babby even formed right now? Okay, start profile. Boom. Processing data. It doesn't even have like multiple. All right, hotspot functions. CPU time seconds 0.0. Others 1.4. Guys, I think this is complete garbage output. LLD. Okay, it got by process. That's fine. Module. I assume this is like memory allocation. No, that's semaphore wait for, guys. It's fucking counting semaphore. Yeah, this is a useless program. Oh, hold on. Maybe this is just summary, though. Hot threads, analyze. Yeah, no, this is useless, guys. All data. We're viewing all data. No, this is trash. I mean, maybe they'll build it into something better, but this is trash. Yeah, no, fuck this. Stupid. Remove programs. AMD. No results. Okay. All right, great. We can't ever remove it. RIP. Wait, that thing had graphs and shit, though. I don't know. Click Saved Configurations. Oh, wrong search box. Okay. Remove programs. Oh, find a setting. Wait, why am I... AMD UProf. There we go. Uninstall. Uninstall. We could try to run VTune in the time we have. Around 1, it's time for me to go, but we still have an hour. Let's try Intel profiling tools. Let's just see what they call them this year. Fix performance bottlenecks with VTune Profiler. So, develop in the cloud, no thank you. The Intel VTune Profiler is part of the Intel One API. Okay, so now their marketing thing is One API. which is horrible. I don't want the one API based toolkit. I want vTune. Windows. Distribution. Installer. Local, please. Download. Continue as guest. Thank you. Are there any current language features I'm considering to remove? Not really. We're probably going to add a couple. We already removed most things. Like the biggest thing that we removed was like constructors and destructors. And yeah, I don't know. SOA, we removed SOA. That actually simplified things a bit, removing SOA. Both of those really did. Does it have Call of Duty? Maybe. You think you can get Call of Duty in 4 gigabytes today? You've got another thing coming. Do we use relative pointers in Sokoban? Probably not yet, but we probably will use them ultimately. We should definitely use them more. Wow, we have 200 people here on a sub-only stream, guys. That's crazy. That's a world record for sub-only stream. Okay. Okay. Why are we still installing? What is going on? I just want to run vTune. What is all this shit? I don't want any of this. It's like Intel does this. It's like every 3 years, they come up with a new marketing name for some initiative and they rebrand everything that they have with that new name to try to get people excited, but like it's the same shit. Prerequisites check. Intel graphics driver for Windows is not found because it doesn't have an Intel GPU, guys. I don't want you to integrate with an IDE. No. Why am I installing all this? I don't even know if I have 32 gigs left. I guess I do. Let's try to remove some Steam games. Oh, we're updating Steam. I can't just run it. Like, why can't I just run Steam sometimes? Like, why is it a whole thing? Operation Riptide. Wait, there's a new CSGO thing with Aquaman? I don't even want to know. CSGO turned into the weirdest, like, indie hack looking game when they did the BR. I don't know what Valve's up to, dude. All right, so let's remove some things. Oh, CSGO is updating. Dyson Sphere program, we could remove that for now. It was fun, but we can install that if we ever want it again. Ghosts and Goblins. Industries of Titan. Moose Life we got to keep. Quake Champions we never played. We never finished Quake expansion packs, did we? We never played like the new expansion pack. I forgot about it completely. Like, can I list games by size? Anyway, we're still installing. I just want VTune, guys. I don't want any of this stuff. Standalone VTune. Well, too late. Too late. Their marketing directed me to the non-standalone VTune. Oh, it's still going past the bottom. Intel distribution for Python. Sure glad I'm getting that. Why didn't I customize installation? Because it didn't look like I could. It didn't. This UI doesn't look like a thing with checkboxes and whatever. I missed a button at the bottom. Great. All right, you know what? The line must be drawn here. Cancel and revert. Delete everything. We're uninstalling all of this. I just simply refuse. I refuse. Okay, so now we're trying to cancel and we can't. And it's just spinning. I'm going to move my cursor in the circular motion so that I can hope that one day we can spin it fast enough that it's done. Like, will it go faster if I... Task manager. There's a thing called Conda index tool running that I'm now killing. Close. I'm just aggressively killing processes now. Installer 32-bit. End task. Oh, that closed the entire thing. All right. GG's. Now I'm not going to be able to remove anything. Remove programs. One Intel. Okay, I don't... All right, now I've got stuff that I'm never going to be able to find and uninstall. Can't believe I trusted the cancel and revert button. Well, yeah. Okay. We're going to try the standalone VTune, and now this will fail to install correctly because a partial install has happened. Or we probably already have it, right? No results for VTune. Great. All right. Sort by installation date. I mean, I think they're just not going to show up here because it probably adds them to this at the end of the process, right? Install date. x64 debuggers and tools. Google Chrome. Discord. Yeah, this isn't, there ain't nothing here. Gas station simulator, though. Let's get rid of that. Maybe you could try Superluminal instead of VTune. Is that any good? I don't know what that is. It's a nice profile. What kind of profiler is it? Oh, look, it's going into one API. Okay, at least this tells us probably where to remove things. No. No, I do not. I do not. Super. Oh, it's made in Europe. I don't know about that. Not EU. The only, it's a sampling I don't want to, sampling profilers suck, guys. I mean, we could try it, but it's not going to work on this program. Sampling profilers are for slow programs because fast programs finish what they're doing before the samples happen. Unless they have very high density sampling, so we'll see. But like my whole problem with VTune, last time I tried to use VTune, is it only would give you a sample every 0.1 milliseconds. Which is basically never, right? We're going to try this. Is this a frickin' React program or something? What is this? I'm clicking next. Okay, it just sat there for a while. I don't care about any of this. I don't know why you are showing me this. I want to run my thing. Okay, so we're going to do all this stuff again. I don't know why I'm doing this. I already know what's going to happen, but we're doing this. Start profiling immediately. Oh God, they have a built-in it's making me not like them. Capture options. Sampling frequency. 8 kilohertz. That's the highest. So that's 8 per millisecond. That's slower than VTune. Yeah, this is going to be useless, guys. Run. Because look, the compiler finishes, the part of the compiler we're trying to optimize finishes in 0.7 seconds. All right. So we're going to get 5,000 samples across the entire run, which is nothing. So you need to then write some test bed that like runs a trillion times and adds all the statistics, which for some reason these programs don't ever seem to give you, right? So like, I mean, this is less good than telemetry so far. Yeah, I don't. So what am I supposed to be able to get out of this? Someone who has used this profiler, tell me what I am supposed to get from this. So this is like the minimum sampling interval, right, is 122 microseconds, right? Because that's 1/8 of a millisecond. So everything looks like it takes 122 microseconds. And everything looks like it's a multiple of that. So you can't really tell how fast things are. This is the thing, sampling profilers are not good. You need to be able to instrument the code if you're going to do this kind of thing. Like, like this kind of profiler is for people who think a millisecond is fast. Do you know what I mean? Why isn't telemetry cutting it? It's not that it's not cutting it. It's just I wanted to try some other tools, right? Like telemetry is useful. I know how to use it, etc. But I wanted to try some other tools that might tell me things. So the reason we downloaded the Intel one was like, oh, is it going to tell me some stuff about memory behavior or whatever, right? Um, but yeah, like this is okay. If I didn't have telemetry, this would be useful data, right? Because I'm looking at this, it's like, oh, I can see what functions are getting called, right? And I can sort of see the pattern of my program. If you had no other profiling tool, this would be useful information. But I have this information, right? How do I zoom out? I have this information is sort of the problem. And in fact, this information is missing a lot of things because there are many calls that are just happening in between the samples, right? So it's even what it's telling me is actually a little bit misleading, actually. I mean, up here it's useful probably like okay, 9 milliseconds, 11 milliseconds, like those big chunky calls are like okay, that's probably accurate. But again, I have that from telemetry, right? Um, and so what I was hoping was that this would give me some kind of other profiling data. What is instrumentation timings? Is there instrumentation? What is this toggling? Instrumentation view is not available because this profile does not contain instrument. Okay. Well, how do I do that? It's not really. I don't know. I don't know, guys. File, new session. Let's try it. I mean, I thought I set capture options. There's no like instrumentation here. I don't know. I don't know, guys. Inspecting, how do I do an instrumentation? Okay. By instrumentation, they mean I add API calls to my program? Is that what they mean? Because that's not classically what instrumentation means. Okay. Well, we're not going to do that because that's not the kind of data we're looking for either. Like, guys, back in the 90s, there's a profiler called Purify Plus from Pure Software, which was then bought by 17 different people, eventually ended up in IBM's hands, and they targeted it to Java instead of frickin' C++. But like, it would actually instrument your program by modifying the machine code to like record all sorts of stuff, and it was fast and it had a good UI and it was very useful. And I don't know, like again, even in that dimension, technology seems to have declined. Like this is a pretty smooth feeling UI here, so that part's good, but the data it's showing me is only useful if I don't have another profiler, and I have another profiler, right? So I don't know. Doesn't. Now, the thing is, we know VTune is going to have the same result, so I don't know why I downloaded it, but we're going to try it to see. How do I VTune? I just want to run VTune. Like, what? Why are you linking me to a file? How do I run the thing? Bin 64. Like, what is this? That was not good. VTune GUI. Okay. Great. All right. We're going to do the same thing we just did, and it's going to be also useless. Shut up. Oh, God, I forgot about all this stuff. Oh, no. What are we in for now? All right. Release. Why can't I even select text here? Thank you. All right, advanced. Environment variables. Analyze child. There ain't going to be much in the way of child processing. There will be a little bit. Let's not bother. Duration time estimate, under 1 minute. Under 1 minute. Are you kidding me? What does allow multiple runs mean? Does that mean if I actually run it a bunch of times, it'll keep it? That might actually make it useful. All right. Run the product as administrator. God damn it, dude. Gee, I'm just going to go here and say run as administrator. Hey, guess what, guys? Oh, it kept it. Unlike the AMD one, it actually kept the things that we put. That's a win. Okay, so allow multiple runs. Okay, boom. Okay, there we go. It sure took a long time. Shut up. Stop it. That like looks so ugly and horrible. Why did they do that to their program? Okay. Um okay. Analysis type. I mean, what we're interested in is this stuff over here, but let's see what they give us. Stop it. This is all stupid and useless. Stop it. Stop it. How do I turn off the help tour? Hamburger menu. Options. There's no way to destroy the help tour. Okay. Okay. Use the C. What? I didn't click this. Why are you telling me it's deprecated? Like, I just want you to do the thing, guys. CPU sampling interval option on the analysis type configuration panel. I don't know what that is. I don't care. Why are we just ran this. Why are we rerunning it? It ran a lot faster that time. It ran it 3 times. Okay. Oh God. Like, what? Come on, guys. Yeah, so we know that we're mostly single core. That's not a surprise to anyone. Um, that makes me so angry. Hash table key value. That's not correct. There's no way that's correct. There's no way that's correct. Well, I wouldn't say no way, but like there's pretty much no way. I mean, maybe. Like what? That would be insane. Maybe we should see what telemetry tells us about this. Like, this would be a good thing to know, actually, if this is really real. This is a thing that I added kind of recently to help factor to help factor the type information system apart, so that we're not storing so many freaking nodes. I could show you where it is. It's just I don't know if I can trust this profile because you see broken profiles so often. But if that's accurate, yikes, right? Let's see. Hold on. Let's close this. Close Steam. Close settings. Close restrict. Close this. Okay, so table key value. It's just a hard-coded hash table I made for, oh, it's for exporting messages. So basically, we want a way to map from nodes to exported versions of the nodes. And it is a big table. Oh, the thing is, this does happen asynchronously with the rest of the program. So even though it's expensive, maybe it's not that bad. It just is bad to be that expensive, though. That's a thing to think about. Okay. Anyway, the reason it might not be that bad, even though it's horrendously expensive, is just because we're limited by our single core stuff. And so this isn't a limiting factor right now. Memcopy in, like, who calls that? No call stack information. Why not? Why not? Do I have to run it with collect call stack information? Do export. So that, again, this seems quite expensive for what it does. I don't know what microarchitecture usage is. This percentage of one core? We're going to have to figure that out. Or no, this is like sort of percentage of runtime, really, if you normalize it. This is like while you're in that code, how often are you using all your execution units and stuff or something? Is this like simulated? What? Okay. Let's just sort this way. Okay, LLD, whatever. I wish I could factor out all that stuff so we don't get the noise. But anyway, so run loop. This is running the bytecode stuff. So again, this is expensive, but again, we're theoretically not bound by it. Like when I look on telemetry, this is running in a different thread than the other stuff. It's chunky. It's chunky, but I don't think it's the limiting factor in how long we take to run right now. Hash table key value, yeah, that's async. Another hash table key value. Oh, find and add are each. That's really quite a lot. Like 240 milliseconds. That's enough that we shouldn't tolerate that. Okay, so the interesting thing is this, again, should be influenced by the memory stuff that I want to do tomorrow. Because once we do that, in fact, this would be a good application of it. Like once we have that, we don't need a hash table anymore. And we could just like cross-reference through this other data structure that we're going to build. And Should be a lot faster. So this is actually good. It's good that we're seeing that this is expensive because that sort of motivates that application of getting rid of this. Now, again, it happens in a separate thread from like the main thread that we're waiting on. But, you know, if it like spams memory a little bit and so, things like that do impact performance of the main thread a little bit, probably. Let's sort by CPU time, not instructions retired. Okay. 200 milliseconds. That's nuts for that. 162 milliseconds. I don't know why this is so slow because I thought that I profiled the hash table and found that it didn't have that many collisions. Maybe I profiled it incorrectly. Maybe we're doing something wacky slow there. But the goal is going to be to get rid of that eventually. Okay. Message exporter do export. All right. Run loop. All right. Critical sections. This is really, is this like time spent sleeping included, or is it time spent before you sleep? I don't actually know. That's got to be the whole time spent sleeping, right? Okay, build 70 milliseconds. That makes sense. Flatten. We would prefer for this to be a lot faster than it is. Do job infer. That's kind of slow. That's kind of slow. Like all of these, anytime we could knock 50 milliseconds off our runtime, that's very good. Are we looking at a potentially bad hash function? I thought that it wasn't. I thought that it was working very well. But maybe I broke something. I don't know. It could be that it's just, see the microarchitecture usage is very low. It could be just that because the hash table is huge and we're randomly accessing across it, that we're waiting on memory all the time, right? That is quite possible. I actually like this view. I don't remember VTune giving me something this useful last time I tried to use it. Okay. Lecture stuff, again, that's async, but you know, we would decrease latency through the system if we made this a little bit faster. Okay. I mean, there's a lot of functions here that take on the order of 10 milliseconds. It's quite possible that a lot of these could be made faster. You know what? Let's try the software sampling because I want to try to get actually, let's see what else. What other information can we get? Yeah, so we don't have stack information. We need to figure out how to turn that on. Maybe the software collection will do that. Yeah, these are just like it doesn't have frickin' stack information. And then here's what all the threads are doing. Ugh, this zoom is horrible. It's kind of unusable. But okay. And then, yeah. This is the kind of like, there's a way that UI code feels really shitty, which is like when they update stuff in threads and kind of display it when it's done. That's totally what's happening here. It feels awful. And there's no reason it should be this slow. Okay. Anyhow. So let's try user mode sampling. It has higher overhead. How do I pick with stacks? It is all grayed out. I can't get any of this stuff either way. How do I get... Maybe the number is the total spent across the 5 times the program ran. Maybe. I mean, can I run it more than 5 times? I'd like to run it 100 times. Can I turn on something here that will ungray this? Maybe I have to select a different analysis. Okay, welcome. Configure analysis. Yes, okay. Memory, let's learn about memory. Sucks. Okay, this is all grayed out again. Oh, these are like different things? No, 1 millisecond. Sucks. It used to be 0.1 millisecond. Can I like say 0.1 here? Nope. Nope. Call stack collection cannot be performed in multiple runs. Why the fuck not? Because of address space layout randomization? Is that why? Fuck you. Dude, we're making such a mess out of computers. Like, there's no real excuse for this, as far as I can think. Why are all these tools like... Why are they just so painful to try and use the way that you obviously want to use them? And why weren't you telling me this for other things? Please disable either multiple runs. Where is that? Okay, multiple runs. That's like, why can't I even tell you how many runs? Like, what? Why isn't this like number of runs 1 and type the number? Like, I'm so confused right now. Do you think it's time I program my own analysis software? We're going to start on that kind of thing, but it won't be this kind of performance analyzer to start. It'll be other things that people don't supply. Like, why is everything like this just so fucked up? Like, just do the obvious things, guys. But they're just... I don't even understand still. Does it matter which one of these I have selected, or are these just submenus and they all happen? All right, so let's run a single one, which is going to suck because of the millisecond sampling, but we at least get call stacks. So I've got that going for me, which is nice, right? Okay, yeah, the CPU time numbers are a lot lower. So I guess in that other report, they're multiplied by... Oh, that actually explains the... Okay, so that explains why this number was so high. It was multiplied by the number of runs. This is starting to make more sense. Hey, look, the amount of collected samples is too low to reliably calculate. No kidding. No kidding. Gee, if only you would collect call stacks while you also let me do multiple runs. And if only you would tell me how many runs. Let me set how many runs. Oh, God, please stop. That one, it was even like off the screen and pointing down. It's like they couldn't even program that correctly. All right. I don't know what I'm looking at now. Flame graph. Great. It's very fiery. We already have this from telemetry. It's fine. This is like a worse, less interactive view. I don't even, like, what? How do I... Oh. So it says 0.6 seconds to load a DLL. That can't be right. That must be like it was hooking that to do some stuff and it took a long time because of that. Yeah, this is just... The frustratingness of this UI is like gonna kill me before anything else. This is really annoying because I want this information while running like 100 runs. And there's no reason they can't do it. It's just they didn't do the work. There's an option icon in the bottom left. This, the help button, this. No, it is not the way. All right, so none of this is actually what we want to really see. This is not anything anyone else doesn't give us. So I still don't... Like, the hardware report was actually useful. This is like just kind of... I don't care. Again, telemetry is better at giving us this. This one... Like, why don't I have this on this one? Do I? And I just didn't... No. So this bottom up is like... just kind of different. Like, I guess... Like, why are these two different interfaces? It's just this is the hardware one and this is the software one, and they're just invisibly different. And the hardware one won't let me filter by module. Can we like sort by secondary sort key? Like I want to sort by module. Oh, this scroll bar is so thin. I want to. Why did people make scroll bars thin? It's one of the worst things that ever happened. I want to sort by module and then sort by CPU time. No, you only get one sort key. Oh, wait. Weird. Interesting. Okay. It's starting to give us information, though. Dude, this scroll bar is so frustrating. It's like right on the edge. There's no padding. And like if I go 1 pixel too, actually, it's less big than it looks. If I go to like the last pixel of the scroll bar, it changes the cursor to like the Windows at this fucking thing that I don't ever want to change. At the bottom, you can filter by module. Ah, yes, thank you. Okay, boom. No, that's just for this. Oh, no, it's for this too. Okay, it just took a long time. All right, this is good then. This is really weird why it still says this is the most expensive thing, because in the software trace, it wasn't the most expensive thing. So like either this is wrong somehow, or it's behaving different under hardware sampling, or the hardware sampling is revealing a problem that the software sampling was not. I don't know. I don't know what to think about this. Like according to this, it's the most expensive function in the whole thing, which I kind of don't believe. It's kind of straining credibility. Should lock the taskbar. I mean, I thought you can't really do that in lock all taskbars. Okay. Okay, that might help. I mean, maybe a little bit. All right. So we have some things to look into later. Like if we can assume that these are relatively accurate. What is load address? I don't even remember what that is. Load address? For a caller in run. Oh, in runner. How? I don't believe this guy. What? What? I don't think I believe these numbers. I think they're horseshit. Oh, maybe not. I mean, no, these could be things that we just call a lot. Actually. And this is a pretty unpredictable branch. Like we're going to be doing, it's like branches in branches, and we do all variants of them all the time. So it could be that this is just very slow because it's not that predictable. That said, it's during the bytecode running. So I don't think that's our limiting factor, but if we could make this faster, that would be good. How do I like... Oh, maybe we could click on the other thing and get the bars. Um, I want to know why this was slow, right? Like, how do I like go look at the code? Does this here we go. Okay, I remember. Shut up. Okay. Um, so the problem is the sampling is very sparse here, right? So you kind of have to take all this with a huge grain of salt. Um, yeah, and this even says that. But it sort of is saying that this call is taking a lot of time. Not that surprising. Um, like, I wish it would just leave all this information here. Like, I want to just scroll through and see this. But I have to go to the other thing and pick it out and only look at that one. Just show me the source code with all the data, guys. Because I wanted to look at store address, but now I have to go like back wherever this was. Like, why is stored? Maybe we just do a lot fewer writes than reads. I don't know. Maybe we didn't get any samples in there at all, right? That could be a thing. Okay, so we don't necessarily have this many calls to this function in the source code, but they're for a bytecode instruction that is very common, which is why I maybe believe this number. I kind of don't like these. Is this the total? Or is this like, usually when we sample this, we're returning somehow? So I actually would have thought that get value type was more expensive, but it says get number flags is more expensive. Let's look at that. I don't think it does a lot, but yeah, like, really? It's a relatively predictable branch. Yeah, let's look at the assembly. Good point. Good point. Like, why don't they just have this view up the whole time? I don't know. With both. Like, just do the thing where I can scroll and see both. Okay, source line. Oh, can I? Nope, it's just showing me this limited range. Okay. 12 milliseconds on this move to memory. Does that mean that like we're filling up the right buffer? Or is that just a sampling error? That's like returning the value of the function. Or not even the value. What is it? We're putting RAX. What is that even doing? What's in RDX? Oh, it's just okay. I think what's happening is it's refactored the code so that this is writing the value for each of because these all point at the same place. So I think it's like it's doing the value. I think it managed to optimize this out into fewer if statements, right? Which is good. And I think it's just putting it locally into RAX and then storing it at the end, which is probably good, right? Yeah, there's like not really a lot of jumps here. Oh, maybe there are. Maybe there are. Maybe it didn't really optimize it so good. It's like these, I kind of feel like it's sampling error though, because so many of these other ones like have 0 samples. But then this one doesn't. But anyway, you can see it's like move extending from the thing, and it's extending by different amounts, right? Which is what all these do, right? Maybe do a branchless version with a mask. I mean, maybe. I would have to think about. The thing is, you sign extend though, right? So we would have to do some weird Hacker's Delight stuff there. The question is just how much do I trust this? Like, what I really want to do is I want to run the thing like 1,000 times and collect samples and aggregate those. And maybe there's a way to do that with this. Have featured content. Okay, it's about time for me to go for now. We might do some perf analysis stuff tonight. I think that the UArch tells more on memory loads. Where, what? So this is the hotspots report. We wanted to do anomaly detection. Like, this is like some X-Files thing, right? We're detecting anomalies. Okay, it's detecting anomalies really requires a time investment, is what we're learning. We really want to know. Okay. No code region of interest found. You have to use the instrumentation and tracing technology API. Rip. Rip. The advanced options are grayed out because it's the default config. You can copy the config somehow. Sample. Okay, new project. Okay. That seems like a very bad choice for them from a UI standpoint, but okay. Again, it's almost time to end the stream, but we'll try some things here. Okay. I don't want to analyze child processes. Oh, but it's sampling. Allow multiple runs. Select finalization mode. What is the consequence of fast? I keep dropping peanuts though. Okay. Well, that's grayed out still. Let's see what happens if we do this. Definitely takes more time. Oh, not that much more. We don't actually need to set the working folder. For this, it compiles fine from anywhere. It just, I was doing that out of habit. How many does it run? Is it just going to run forever now? I mean, I like this. This is definitely what I always wished VTune would do. I just wish I knew how many times it's running and or like basic usability things like this. Like tell me how many times you're running it. Which iteration number are we on? Are you running it infinitely and do you expect me to do something? I don't know. It might be because I chose from 1 to 15 minutes duration. Maybe. How do I know that? What, like, it's so ununderstandable for no good reason. Running until it had 1 gig of data. Then show me how much data you have. tell me right here, we only have 1 megabyte of data and we're going to run for 17 months until we have a gigabyte of data. Like, let me know. Okay, stop and cancel are different. So I'm going to assume that maybe stop is okay to press. Great. Like, you could add so much value to the world just by making a tool like this and not making it unusable garbage. So valuable. Okay. Let's try this again. What do you think we should do here? Guys, I get so mad at this kind of stuff, I can't even tell you. Like, I'm ready to throw my computer out the window right now. Like, it's so incomprehensible. Like, why is everything grayed out? Is it because this one already launched? And you don't use this UI to relaunch? Then why does it look like a UI that I would change? Okay, people are saying customize a copy. Okay. Now this is not grayed out. My comments. Why are these comments? What do you mean my comments? What is that? What does that even mean? My comments dot what? Okay, I just clicked on something and the whole UI moved because it added these things. Memory bandwidth collection cannot be combined with either with call stacks or context switches. Okay, well, we're not going to do stacks. Is PEB's data context switches? No. Where's context switches? I don't even know. Do you mind telling me where that is? On the left in advanced. Okay, maybe. Oh yeah, multiple runs. But we turned off call stacks, didn't we? Why is it saying we turned off call stacks? We said no stacks. Or is this part? Okay. This turns on stacks even if it's turned off. Okay, our IQ is approaching 24. Okay. Analyze memory bandwidth. I don't even know what we're doing anymore. Duration time estimate under a minute, please. It's deprecated. Use the CPU sampling interval option on the analysis type configuration pane. What is that? Okay, it's going to get mad if I don't. Okay. RIP. It's just going to run forever again, right? This is kind of an escape room, actually. There's a setting to stop the collection after n seconds. Okay. Wait, I clicked the button, but it didn't stop. Now it's stopping, maybe? Failed to finalize the result. The result you are opening is empty. Time to rerun, try to rerun the analysis. Where is this thing to make it stop after some amount of time? There is a setting to stop the collection. Ah, okay, this. Time from collection end. What do you mean? What's collection end? We're trying to set the end of collection. Let's try 30 seconds. I don't know. I literally, okay, 20 seconds is the most. I have no idea what that means. Let's try it. Oh, wait, this is grayed out now. Collected data size cannot be limited by the timer option if multiple runs. Oh, fuck. Goodbye. I can't do it. I can't do it, guys. I'm going to have to store up more energy for dealing with this stuff and try to recharge and come back later. How's it going, everybody? It's time for me to go soon. Any questions about the fun profile? Mostly we just dorked around with profiling tools that are too hard to use for no good reason. We did get a little bit of insight. We tried to optimize a couple things and they didn't get faster. Still, the most useful data that we have is from telemetry. Although some of that Intel data might be good. Some of that sampling data might be good if we can figure out how to use it. But what I really miss, there were some Intel tools like 10 years ago that would do things like run a simulator on your code and like tell you probably what the problems were. And maybe that simulator was too inaccurate. Maybe it requires programmers to maintain it who are better than the programmers they have now. I don't know. But I remember that that thing was kind of useful, or seemed kind of useful. Anyway, this information is, we have relatively high confidence in its accuracy. And it definitely tells us some things that we could make faster, probably. So new information that we discovered today, need size to build and need size to build batch are slower than we would like. It's 13 milliseconds. Ideally, those would be much smaller, like almost zero. And the question is, how do we figure out how to make them almost zero? Let's do one last thing before we sign off. Let's try to corroborate. So the Intel thing was telling us that the type, what was it called that we searched for? One of the hash tables. What the hell was it called? It was in Message Exporter. Exported table. Yeah, this one. Hash table key value. All right. So what if we just profile these for a second, and let's just see if they show up really big. If they do, that will corroborate and give us more confidence in the VTune data that we're getting, right? Let's see. Failed to set the, because we're already running somewhere else. VTune is still running us, guys. That might be why it was like failing. Or no, maybe not V2, because did we accidentally put the telemetry binary in there at one point? I don't see it running. Why do we have a trillion con hosts? That's bad news. Failed to write the file. Failed to set the icon. This is bad news. Now we're not going to be able to do anything because we have a zombie process that we can't see or something. Good thing we're running node.js. That's going to help. This is just going to... Oh, God. Now we have that problem, too. I have my work cut out for me. Yeah, we just can't. That simulator was called Intel Architecture Codes Analyzer. Does it still exist? Kill all con hosts? Well, I want my con hosts that I'm using. Good thing we have a lot of Steam Web Helper, guys. It's really helping. End task. do you guys get black screen when Task Manager is up, or do you actually? No, it looks like you see it. End task. Like, I feel like VTune just left these running. All right, those were the ones we were trying to use. Good to know. All right, now let's see if we can run anything. The answer is probably no. We probably can't, but okay, release build. Release build can't even write the output file either. Everything we ever ran from VTune is like still locked somehow. Reboot. Yeah, I mean, it's basically reboot time, guys. And it's time for me to sign off anyway. I had wanted to get this last measurement. Actually, we probably did, because we don't need it to like successfully link. So probably we could just look at this. It'll be like a little bit different because we don't have the linker time. So the numbers won't correspond. The percentages won't correspond to previous runs. But okay, so the message exporter stuff, that's like one of these. Okay, that's here. So this is all hash table key value, whatever. It's usually fast, but there's a couple times when it's slow. So like here, 100 million, holy shit, dude. Okay, the resize took 30 milliseconds. You can see it's growing gradually. So we took 7, and then we took 14, right? Because it's doubling in size. So we're resizing it as it gets real big. And even though this is in a separate thread and we're not really blocking on it, this is affecting the latency. Well, okay, this is weird, guys. This is weird because I would have thought this is totally asynchronous with our main thread. But you see here, there's a giant hole right here where we're waiting for this thing to happen. So like we might be done handling stuff and then waiting for messages or something. I think we only do that when there's no work remaining to do otherwise. Anyway, okay, so clearly this takes a giant dookie all over our, like we could save 30 milliseconds here if we weren't resizing this table, probably. Which that's a significant amount of time. That's a very significant amount of time. So I think that's the plan. So during the marathon tomorrow, we are going to be rearranging the data structures. It's going to be fraught with peril. It's going to be very difficult. I don't know if we'll end up with a running compiler at the end, but if we do, then we will be in a position to do things like get rid of this hash table, which will be good. Yeah, it is a little redemption for VTune because VTune told us this might be a problem. And now we discovered that it is a problem. Although, yeah, it is a problem. So that's good. These ones aren't a problem, these earlier resizes. I mean, we still would like to not be spending like power on our CPU doing this stupid crap. But at least during the earlier resizes, you see that we're not waiting on them because this thread has other stuff to do. But by the time we get to this one, we're out of other stuff to do until this plus some other things like finish, right? So it's like this, and then that probably sends some messages. We would have to correlate to the message thread, but this probably then sends some messages, which then the user program does some stuff, and then eventually that comes around to the pump here. But it's like a long time. Now, if I thought we needed that hash table in the long term, I would try to think of preemptive ways. Like you could, right after sending a message to the user program, you could preemptively resize or something. But this is just bad. So in compilers generally, you want to avoid things that get slower as your program size increases, right? So for Sokoban game, we do a 30 millisecond resize here. And we do a bunch more stuff after that. So you could imagine, like looking at this pattern, we're probably almost at the point where we're going to do a 60 millisecond resize, right? And then for a bigger program, we're almost at the point where we're going to do 120 millisecond resize. Like this just has to go because it'll just keep growing without bound, right? So that makes me happy to know that. Semaphore seems to start waiting before the hash table starts resizing. Yeah, that's fine. That all makes sense. I'll explain that some other time. Yeah, we're not waiting directly on this thread. We're waiting on the user meta program to get back to us. And the user meta program is waiting on this, okay? Among other things. So this kind of makes sense. I don't think this is coincidence, right? Like if we run this again, let's just run it again. And I believe we'll just see that pattern again. It should be similar enough, right? So here's a giant hole. Here's that hash table resize. See that? Bam. Exactly the same. So that's good to know. All right, everybody, time for me to go. Thanks for coming by. We may stream tonight. We'll see. See you later on. Thanks for coming by to our Elite Sub only stream.